Hey guys, welcome back for our math review. I'll be going over Wednesday's math review for you guys today. So let's dive right into our first problem, Alex and Abel. So we know we're going to have two friends, right? So let me pick we're going to have two friends, Alex and Abel. They buy a chocolate bar, which means there's one chocolate bar. We got to keep that in mind. They each eat 2/7 of that one chocolate bar. Okay, now the question, how much of the chocolate bar is remaining? So it's not really asking us how much did they eat together. It's asking us how much was remaining after they each ate 2/7 of a chocolate bar. So I like my fraction bar model, and I know that my unit fraction, because my denominator is in 7, that means that my unit fraction for this is going to be 1/7. So I'm going to break down my fraction bar into 7 pieces using 6 lines. 1, 2, 3, 4, 5, 6, 7. So I know Abel ate 2/7, so I'm going to put 2 above Abel. And I also know that Alex ate 2/7 as well. So I'm going to go and color in the 2/7 of my fraction bar because that's what Abel ate. Then I can go color in 2/7 more because that's what Alex ate. So what I now know is that together, Alex and Abel ate 4/7 of this chocolate bar. But the question's not asking how much they ate together. The question is asking how much was remaining. This was the big word that helped us understand what was being asked of us. So now I'm going to be looking at what's left. And each one of these bars that's left represent 1/7. And if I combine them together, I've got 3/7. So I know that Abel and Alex ate 4/7, but there was 3/7 remaining. All right, on to the next one. So now we've got an area model problem dealing with operations in base 10. This is a multiplication problem, and I know that we've mastered area model, so this shouldn't be difficult. How am I going to set this up? I'm going to set up my 3 as my multiplier because I know there's only one place value, so that belongs here on the left. There are 4 place values being used for the number 1,562. But there are only 3 here. I know that I could break these up possibly to be easier to work with. So I'm going to set it up with 1,500 here, 60 here, and 2 here. So inside this first box, we're going to do 3 times 1,500. The second box, we're going to do 3 times 60. And then the last box, we're going to do 3 times 2. Sorry if my handwriting is a little sloppy. Let me see if I can fix that. 3 times 60. All right, so now I'm going to multiply 3 times 15. How do we do that? I know that 3 times 15 will give me 45. But I can't forget about those extra zeros, right? Remember our base 10, guys. We've got to add back those double zeros, okay? So now this box is equivalent to 4,500. 3 times 60, I know I could multiply 3 times 6 and just add out that extra 0. 3 times 6 gives me 18, and I know I want to add back that last 0 from 3 times 60. So I get 180. And then for my last problem, it's 3 times 6. We all know our math facts for 3 and 2. 3 times 2 gives us 6. So the last step, we're not done. We have to add up the sums of each of the boxes in our area model. So I'm going to do that for you really quickly. Let me get another color. So I've got 40. Let me erase that. Excuse my handwriting. 4,500 in one box, I'm going to check it off. 180 in another box, I'm going to check it off. And I've got 6 in the last box. I'm going to check it off just to make sure that I've got all of them. And then I even want to make sure that everything is lined up. My ones, my tens, my hundreds, and my thousands are all lined up perfectly. 0 plus 0 plus 6 gives me 6. 0 plus 8 gives me 8. 5 plus 1 gives me 6. And 4 plus nothing gives me 4. So 1,562 times 3 equals 4,686. Okay? You always want to make sure you're double checking this with a second strategy that you're comfortable with. On to the last one. Which figure has one or more obtuse angles? So right away, I know I'm going to have to figure out which of these 4 figures has one or more obtuse angles, but right away, I just want to establish what's an obtuse angle. As long as we know, then we should be writing it out inside the box. So we know that an obtuse angle is an angle that is greater than 90 degrees, but less than 180 degrees. So once you have that written down and you know what that means, then you can dive into this problem, understanding the important vocabulary that you need to know. So I'm going to take a look at number 1 right here. And it says, which figure has one or more? And I know that a right angle is 90 degrees. So all of the angles in these figures should be greater than a right angle and less than a straight line, right? So in this figure, I know that a right angle looks much larger than this angle here. So this must be an acute angle. And since this looks like an equilateral triangle, I know that all 3 of these angles are acute angles. So A couldn't possibly be the figure with one or more obtuse angles. All 3 angles are acute. This isn't acute. These are all acute angles. Okay. Here's the second one. We've got a nice 90-degree angle here. I'm holding my paper up, the corner of my Post-it up to the math problem, just like I showed you guys in class, right? A right angle template can be made out of any piece of paper, okay? So now I know I have one right angle, and these angles, as I line up my right angle template, are smaller than the right angle template, which means these are both acute angles, and this is a right angle. So this figure does not have one or more obtuse angles. Now on to the last one. I've got my right angle template handy, and I'm lining it up so I know this is a right angle, this is a right angle, this is a right angle, and this is a right angle. We also know it has 4 right angles because it's a rectangle. All rectangles and squares have 4 right angles. So this couldn't possibly be a figure with one or more obtuse angles. Last but not least, I'm going to hold up my right angle template to this angle right here. And it shows that this angle is larger than my right angle template, but it's smaller than a straight line, just like we had stated previously down here. So this one definitely has one or more obtuse angles. All of these angles look identical, and I know they're all greater than 90 degrees because I've used my right angle template. So this is our figure that has one or more obtuse angles. All right, so little messy. I hope everyone paid attention. We worked on our fraction word problem using a bar model. We worked on our multiplication problem using an area model, and we identified a figure with one or more obtuse angles by understanding the definition of an obtuse angle. Good work, guys. Keep it up. Don't forget that the quiz is on Friday, and we've got to study hard so that we can do well every Friday. Thanks, guys.